In this video, I will talk about solving applied problems with the use of a quadratic equation. Once you determine an equation from the problem, you can solve it either by factoring or by using the quadratic formula. Also, these problems can be solved by using either the one variable or the two variable method for labeling the unknown. Over the years, I have found that most people prefer the one variable method, so that is the method I will use when solving the problems. If you would rather solve them with the two variable method, you can certainly do that. Here's the first example of an applied quadratic problem. The length of a rectangle is 5 inches more than the width. If the area is 66 square inches, find the dimensions. As with all the other applied problems, the very first thing I want to do is I want to identify what I am going to let x equal. And in this case, it makes sense to let x equal the width. It says that the length is 5 inches more than the width. So, using the one variable method, I'm going to say that x plus 5 is equal to the length. In order to find the area of a rectangle, you multiply the width and the length together. So my equation would be x times x plus 5 is equal to 66. At this particular point, this does not really look like a quadratic because I don't have the x squared. But the only thing I can do to solve this is to get rid of the parentheses. So I'm going to get my x squared. I have x squared plus 5x is equal to 66. And now I have my quadratic equation. The very first thing I want to do is I want to go through and I want to make the one side equal to 0. So I'm going to subtract 66 from both sides. So now I have a quadratic equation equal to 0. As I take a look at this, because this has a coefficient of 1 in front of the x squared, I could probably go through and factor this. You could certainly do this if you wanted to by the quadratic equation, but factoring this would also work fairly easily. I know x times x has to equal x squared, and I know that I have to get two numbers that equal 66, so when I add or subtract them, I have a 5. Well, the 11 and the 6 make a lot of sense, so I'm going to put an 11 and a 6 in here. And then once again, because this is subtraction, I know one of these has to be addition, one of these has to be subtraction. So I'm going to have x plus 11, x minus 6 as the two different factors for that. And once again, if you FOIL that, you will see that that does work. So now in this particular case, I want to set both of these equal to 0. If x plus 11 is equal to 0, that means x is equal to negative 11. If x minus 6 is equal to 0, that means that x is equal to 6. So my width is what x was equal to, and I have two different possible answers. X is equal to negative 11, x is equal to 6. Well, it's certainly not possible to have a width of a negative number. So in this applied problem, I'm not going to have that for an answer. My answer needs to be this x is equal to 6. So the width of this is 6, the length of this is 11, and certainly 6 times 11 does equal 66. Here's a second example. The sum of the squares of two consecutive odd numbers is 74. Find the numbers. The first thing I'm going to do is I'm going to do my labeling. So I might say that x is equal to the first number. And if they're consecutive odd numbers, the second number has to be x plus 2, because there's a difference of 2 between two odd numbers. Then I want to come up with my equation. It says that the sum of the squares of two consecutive odd numbers. So I need the first number squared added to the second number squared, because I want the sum of the squares of those numbers has to equal 74. So here's my equation, and then I just need to go through and solve that. And I'm going to do this fairly quickly. I get x squared plus. Now that x plus 2 squared, remember, means x plus 2 times x plus 2. So I'm going to apply the FOIL method in order to figure that out. So that's equal to x squared plus 4x plus 4 is equal to 74. Now I'm just going to combine my terms. I have an x squared plus an x squared, so I have 2x squared plus 4x plus 4 is equal to 74. In order to solve this, I need to make the right-hand side equal to 0, so I'm going to subtract 74 from both sides, and I get 2x squared plus 4x subtract 70 is equal to 0 when I subtract 74 from both sides. Now at this particular point, I just need to solve that. One little thing that I could do here is I could make this equation on the left-hand side a little bit easier. Notice that each one of these coefficients is an even number. I'm going to divide both sides by 2. And when I divide both sides by 2, I end up with x squared plus 2x subtract 35 is equal to 0. This is not something that you necessarily need to do. You could have just gone with this, used the quadratic formula, and figured it out, but this is one way that might make this a little bit easier. At this particular point then, because I have a coefficient of 1 in front of the x squared, I'm just going to go through and solve this by factoring. I know x times x is equal to x squared. Since this is a subtraction, I know one has to be addition, one has to be subtraction, and I know that 7 times 5 does give me 35, so this is 7, this is 5. Setting both these equal to 0, I get if x plus 7 is equal to 0, x is equal to negative 7. If x minus 5 is equal to 0, then x has to be equal to 5. This is a problem in which both of these solutions will work. If x is equal to negative 7, that means x is the first number, which would mean that the second number would have to be negative 5. It says that the sum of the squares of two consecutive odd numbers. Well, if I square negative 7, I get 49. If I square negative 5, I get 25. And certainly if I add those together, I do get 74 for an answer. But at the same time, x could also be equal to 5. If x is equal to 5, then that second number is 7. And once again, 5 squared is equal to 25. 7 squared is equal to 49. I add those together and I do get 74 for an answer. So for this, I would need to give two different answers. I would need to say that possible answers are negative 7, negative 5, or 5 and 7. This is a great applied problem dealing with manufacturing. A square piece of sheet metal is to be made into a pan by cutting 2-inch squares from the corners and then turning up the sides. If the volume is to be 128 cubic inches, what size sheet metal is needed? Now you can see I already have drawn the pictures and gone through the problem here, but I do want to explain what I did. I thought having the picture here would be helpful, and I certainly would be drawing a picture as I go through. It said in here that I wanted to know what size sheet metal is needed. So I went through and I said, well, I have a piece of sheet metal and I'm going to set the sides equal to x. And since it's square, both sides are equal to x. It said I'm going to cut 2-inch squares off. So I'm going to go through and I'm going to cut off these 2-inch squares right here. So if I were to cut those things off, notice that the distance from here to here is 2 inches. The distance from here to here is 2 inches. That would mean that the distance from here to here would have to be x subtract 4, because the entire distance from here to here is x. If it's x minus 4 from here to here, that would mean obviously it would have to be x minus 4 also from here to here, because I am dealing with a square piece of sheet metal. Now, one important piece of information that I need here is I need to know the formula for volume. The formula for volume is the length times the width times the height. When I cut off these 2-inch pieces on the sides, and if I fold this up, if I folded all these up, that would mean that the height would be 2 inches. So you can see that what I have here is I have this particular equation. X minus 4 is the width times x minus 4 is the length times the height is 2. And then let me walk through what I did in order to solve that. The very first thing I did is I said, boy, it'd just be easier if I divided both sides by 2. If I divide both sides by 2, I'm going to divide that 128 by 2, and I am going to be getting 64. So now I have x minus 4 times x minus 4 is equal to 64. Now at this particular point, I'm going to apply FOIL to x minus 4 times x minus 4. Now this should be x squared. It just did not come out correctly. But I have x squared subtract 8x plus 16 is equal to 64. And then I went through and I subtracted 64 from both sides. Once again, this is an x squared right here. And I have x squared subtract 8x subtract 48 is equal to 0. If I go through and factor that, these are the two factors I get. X plus 4 times x minus 12 is equal to 0. And certainly setting both of those equal to 0, if I have x plus 4 is equal to 0, I get x is equal to negative 4. Well, negative 4 certainly will not work in this particular problem because I cannot have a piece of sheet metal that has a side of negative 4. But x minus 12 does work. Because x minus 12 is equal to 0, that must mean x is equal to 12. So my original piece of the sheet metal is a 12 by 12 piece. And I can certainly go back and check and make sure that that works. If it's the original size is 12 inches by 12 inches, that would mean that this would be 8 inches and this would be 8 inches. In order to find the volume, I multiply the length, 8 inches, times the width, 8 inches, times the height, and I have to get 128 cubic inches. Well, certainly 8 times 8 is 64, times 2 does give me 128, so this problem does work. Notice there's no way I would try and go through and do this problem without drawing a picture. And in many of the problems that you'll be asked to do, you will probably want to be doing the same thing in drawing a picture. In this video, I have given you 3 different examples of the types of applied problems you will need to solve with quadratic equations. As with any new skill, practicing additional problems is always helpful. In the next and last video of this module, I am going to give you some more problems to solve, and then let you watch how I might go through and solve them.